Hi everyone. So this is example 2 from the lesson on using the second derivative. It goes with lessons 5, 6, and 5, 7 from AP Calc. But this is also a really good summary of everything involving the first and second derivative tests, right? Where we're looking for critical points, inflection points, all of those kinds of things. All of the analysis that we do using derivatives. So this is a good one to kind of circle back to as we're heading into like quiz or test time for Unit 5. Okay, so I've got this function f of x. I also want you to pay attention, by the way, to how I'm like writing and justifying things and how I'm showing my work, okay? So back to what I was saying, location of critical points. So we want to ask ourselves, what do we always know is true at a critical point? Well, a critical point is when, I'm trying to keep my color scheme consistent here, it's when f prime equals 0. Right? I know that that's what I want to try to figure out here. So let's find f prime. F prime of x would be 3x squared minus 12. Okay, and we want to set that f prime equal to 0. Okay, well, 3x squared then would have to equal 12. So x squared would equal 4. And don't fall in the trap here. When you take that square root, we're going to need a plus or minus, right? So x is plus or minus 2. Okay, so location of relative extrema. I'm asking you about relative mins and maxes. And really, I mean, the order of the questions here is a little off. But what I really need to know is this down here, right? The increasing and decreasing intervals. So I'm going to kind of do that work all together, and then we'll just answer both of these questions. Okay, so my relative extrema, what I want to be looking at is where those critical points are. I'm going to do my number line, and I'm going to put -2 on here, and I'm going to put +2 on here. And I want to test points that are in those intervals, right? So this thing has kind of been divided into 3 pieces. And I want to know, is my derivative, my first derivative, positive or negative? So I might test, let's see, -3. In this interval, I definitely want to use 0. And then up here, maybe I'll use +3. And I'm testing it in my first derivative, which is this thing right here, the 3x squared minus 12. Okay, so if I put -3 in there, -3 squared is +9, so this is going to give me a 27, and 27 minus 12 comes out positive. If I put 0 in there, 0 squared, 0, this whole thing is 0, 0 minus 12, that's going to give me a negative number. And then the +3 actually should come out the same as the -3 because of the symmetry of a quadratic. That's what this is. But if you need to test that, 3 squared is 9, 27, 27 minus 12, this comes out positive. Okay, so now what this question was asking me is where are my relative extrema, right? And so I know it's going to be these points, but I just need to decide, are these maximums or minimums, okay? Well, if my derivative changes from positive to negative, that means my original function was going from increasing to decreasing, and then here it'd be going to increasing again, okay? So that means this -2 must be a relative maximum, and this +2 must be a relative minimum. That's how I'm going to answer this question. So x equals -2 is a relative max. It didn't ask me for a justification, but you know I'm going to justify anyway, because f prime changes from positive to negative. And then I would say, oh, I'm sorry, I meant for this to be -2. I meant to start with the -2. Oh no, that's going to mess us up. And then x equals +2 is actually a relative minimum. because f prime changes from negative to positive. Okay, so that's my answer about the relative extrema. And again, sorry I messed that up. I was talking about this point. I just didn't write the -2. I'm going to go ahead and answer these increasing and decreasing intervals right now because that's really what we just figured out, right? Remember that on this number line, this is negative infinity and this is positive infinity. So I would say that we are increasing on the interval from negative infinity. Remember, your infinities always get the curved bracket. So from negative infinity up to -2. And from +2 out to positive infinity, because f prime is positive. Decreasing on that little interval in between, right? So from -2 to +2, because f prime is negative. I want you to notice kind of how concise I'm making these explanations. I'm not getting super wordy. I would probably, if this was the AP test, be writing out the full word because, right? But other than that, like this is what I need to see. This up here, the changing from negative to positive, that's what I need to see, okay? I don't need a lot of verbal explanation. I just need you to talk about the math. Okay. As soon as we see absolute extrema, and specifically when we're on an interval, our brain should be saying, oh, we need to do candidates test here, okay? And there actually is something a little bit weird about this candidates test. I mean, it's not terrible, but... So let's do a candidates test. I'm going to set up my XY table. And remember, in that XY table, what I really need are my endpoints of my interval, so -1 and 3. And then I would need my critical points. Now, my critical points we said were plus and minus 2. The weird thing about this is that one of those critical points is not even in this interval, right? So I don't even want to consider it as an option. So yes, normally I would put -2 and 2 both in here, but because -2 is not in this interval, I'm only testing the +2. And remember that I'm testing these in the original f of x function, because what I'm talking about is the original f of x function. So here's my function, this x cubed minus 12x minus 5. I'm going to try to talk you through my mental math here. -1 cubed is -1. Minus 12 times -1, so that's really going to be like a plus 12 and then minus 5. So that's going to be a 6. Okay, when I put the 2 in here, 2 cubed is 8. Minus 12 times 2, so minus 24. Minus 5. Okay, so I think I'm going to get -21. -16, yeah, okay, -21. And then 3 cubed is 27. Minus 12 times 3, so 36. Minus 5. Okay, this is -9 minus 5, so this is -14. Notice the question asked for the location, not the value. So in my answer here, I'm going to say, just want my colors to stand out here, that I have an absolute min located at, my minimum value would be this -21. So located at x equals 2. And an absolute max located at, this is the only thing that's positive, so this would have to be my absolute max. X equals -1. Now, if I wasn't sure about whether I should be saying the x value or the y value, I would word this a little differently. I would say something like, I have an absolute minimum of -21 at x equals 2. And I have an absolute maximum of 6 at x equals -1. That's the best way to kind of cover both of your bases if you're not sure which one it's actually asking for. Okay. Okay, let's head down and talk about inflection points here. So inflection points is when we start talking about the second derivative. So let's look at what f double prime of x is. My f prime, you can't see it up there, but it's 3x squared minus 12. So I believe this would just be a 6x because the minus 12 goes away. Inflection points are where does this thing equal 0, right? So 6x equals 0 when x equals 0. So that's my inflection point. And I forgot to write this in, that inflection points, this is the math that I'm doing, right? F double prime equals 0. Okay, so for my concavity intervals, I'm approaching that very much the same way that I've approached the increasing, decreasing, right, with the number line. So for my concavity intervals, I'm doing this, but I'm putting my inflection point of 0 on here, and I am testing inside my second derivative. So it's my second derivative that I'm testing. I want to test something smaller, and I want to test something larger than 0 in my second derivative function, which is right here. And really, this should make sense to you. If I put anything negative in here, this is going to come out negative. And if I put anything positive in here, this is going to come out positive. So it makes sense to us why this switches at 0. So for my answer here, I would say concave up on the interval from, I guess I could have started with concave down, but from 0 to infinity. If I had to give a justification, I would say because f double prime is positive, and concave down on the interval from negative infinity up to 0 because f double prime is negative. Okay, so that gives you kind of a whole picture of everything I could ask you to do with your derivatives. So I'm trying to make it so you can see the whole thing at one time. Not working so well with this document camera, but that's a little bit of everything that I could ask you in terms of function analysis, which is what this chapter is kind of all about. And then the next lesson kind of gets into how does all of this same stuff show up on a graph rather than looking at an equation to start out with. So hopefully that's sitting okay with you. Feel free to ask questions in class if you've got them.